Hey everyone! In this video, I would like to take a look at inequalities that have three parts. These are also sometimes referred to as compound inequalities. So the first thing I want to do is actually just take a look and talk about a few important notes about these types of inequalities. So just to give you an idea of what this looks like, we're going to have three parts to this inequality, which means we're going to have two inequality symbols. So for example, maybe I have A is less than X, and that's less than B. So basically, I'm saying that X, whatever X is, happens to be somewhere between A and B. On a number line, it would look like this. So we have our two values, A, we have B, and then X can be anything in between A and B. So it's describing this interval. I can mix and match my inequality symbols as well. So maybe I have A is less than or equal to X, less than or equal to B, or we could do A is less than X, less than or equal to B, or we could do the last possibility here, A is less than or equal to X, which is less than B. So in each of these following cases, we're saying whether or not we're including these endpoints. So in this one, A and B are both included in the interval. Here only B is, and in the last one only A is. So a couple important things. When I'm writing an inequality of three parts, the two inequality symbols, they both have to be pointing the same direction. So if I were to write an inequality, A is less than X, but that's greater than B, this inequality wouldn't make sense. If I were to try and write this on a number line, it would be a little messy, right? It's conflicting. Or if I were to go the other direction, if I were to say A is greater than X, which is less than B, it's the same thing. These are no good. The other important note is we want to make sure that both of these inequality signs are pointing towards the lesser number. So basically, we want everything to go in numerical order. So if I look at this first one I wrote, I'm starting at A, and then A is the farthest left number on my number line. And then X is everything in the middle, so that's why I shaded the middle here, and then B is the farthest right. So I'm going from the smallest number, working my way up to the biggest one in numerical order. Okay, now let's take a look at how we solve these. So important thing to note, in all of these inequalities I wrote, in the middle is my X value. So when I'm solving an inequality with three parts, I want to work this down until X is all by itself in the middle. And when I use my algebraic properties to help me solve this, whatever I do to that middle, I also need to do to the two outsides. So in this example, I have negative 2x plus 5 in the middle. So I need to move the 5, I need to move the negative 2. So let's start with subtracting 5. So if I subtract 5 in the middle, I also have to subtract 5 from both sides. So we're going to end up with negative 8 is less than negative 2x is less than or equal to 2. All right, so far so good. Just taking a look at this inequality, it still makes sense, right? Negative 8 is smaller than negative 2. Negative 2x is describing everything in between. To get the x all by itself, let's finish up by dividing by negative 2. Again, if I divide the middle by negative 2, I need to divide the far right and the far left by negative 2. So we end up with negative 8 divided by negative 2 is 4. In the middle, we'll have just x, and then 2 divided by negative 2 is negative 1. All right, now I didn't write the inequality symbols in here yet because just like when you're solving a normal linear inequality, whenever we multiply or divide by a negative value, we need to switch the signs. And just looking at the order I have these values in, I know that negative 1 is smaller than 4. So that means that when I put these symbols in, I need to make sure that they're pointing towards that smaller number. So I switch both of them. Now this isn't in numerical order, it's kind of going backwards. So what we can do is I can just reverse everything. And then this is normally the way that we would write it. So -1 is less than or equal to x, which is less than 4. Okay, we can also describe this in a couple different notations. So I can use set builder notation. So I can say all the x values such that -1 is less than or equal to x, which is less than 4. I can write this in interval notation. So I'm describing an interval that goes from -1 and it stops at 4. Here I'm doing a square bracket on the -1 because I do have the or equal to, so I want to include -1, but it's a parenthesis on 4 because we're not including that one. And then the last way we can represent this is on a number line. So let's put our interval on here. We need to make sure we go from -1 up to 4. So we'll say that this is 0, 1, 2, 3, 4, and -1. Okay, on the number line, so at -1, I'm going to use a closed circle because I do want to include that point. But on 4, we're going to use an open circle because that one's not included. And then we want to shade everything in between. So here's our 3 different representations for this inequality.